In this video, we're going to take a quick look at deep compositing. So what is deep compositing? Well, you may have already encountered the Z channel in a 3D rendered image like this. This is the depth channel. It stores a sample for each pixel's depth in the scene. I'm kind of remapping it here for the viewer so we can see it better. So each time the renderer goes through and samples a pixel, it accumulates the pixels together and then takes a depth sample and kind of stuffs it into that pixel. Now this is a little tricky because anti-aliasing is actually kind of hard on a depth channel like this because it's not really 100% valid concept. A pixel pretty much has to either be here or it has to be there. There's no way to really filter it for anti-aliasing because that's an invalid concept. So if we tried to use this channel for compositing something in depth, we're not going to get the greatest result out of this particular Z channel, a classic Z channel, because it doesn't have any anti-aliasing. But the way that the anti-aliasing is built up requires a bunch of samples. So we're going to look at the RGB image here again. And anti-aliasing is this sort of out of focus edge that you see here, the soft edge. Really, it is a form of blurring, but it's a form of accumulating the oversampling of that edge. So what happens in the renderer is it's shooting a lot of samples at the same pixel, but with a slightly different position for each sample. And then it filters all of those samples back into one pixel, and then hence you get this soft result. It really is a way of taking a virtual oversampled image, like a larger size render, and then filtering it down into a smaller sized output raster. If you were to do that to the Z buffers, they would get anti-aliased on the edges, but then they wouldn't be valid Z buffers either, because when you'd soften the edge, that value, well, it wouldn't describe something that was clearly here or clearly there. It would be some linear interpolation of the two values, so it would lose its meaning as a Z buffer. What deep compositing attempts to do is store a sample for every single, or store a Z record for every single sample that has been made when the thing was rendered. So because of that, they're not really directly viewable in the viewport here, though we can look at it. So let's take a look at the Z buffer. We're going to attach to this, and not the Z buffer, but rather the deep channel. So here's the deep buffer, and I'm going to try to map it down so we can look into it a little bit here. And they not only store a sample for the front, which is in the red channel here, they also store one for the back. And they're storing every single, the Z depth for every single sample that has been shot. Well, not exactly, I exaggerated. They're intelligently storing the sample for everything. So here we have the deep sample node, which will allow us to sort of probe our image. You can see along the front here, there's really only one sample for every single pixel. But as we go along places where it's had to anti-alias or maybe shoot more samples, this was because this was rendered with an intelligent compression turned on out of Arnold. So it knew that it could throw away these samples here because there's really no reason to store all these samples along the front shell of this. But as we get towards the edges and we have anti-aliasing and maybe blending, it was smart enough to keep more of those samples until we get to the very edges, and it keeps pretty much a depth sample for every single sample that it has shot. So that's very convenient. A good renderer should be able to do something like this. If this was a volume, it would have to shoot the samples through the entire depth of the volume. So each sample would get its own depth, and it wouldn't have the ability to do this sort of clever compression of the samples. So hence these depth buffers, these deep buffers could get very, very large as you're storing more and more samples per pixel. It's storing a red, green, and blue sample for all of those as well. So it's keeping all of the samples around all of the time. It's not completely compressing it into a traditional image when you do deep rendering. Traditional compositing won't really work with these deep buffers, though if you want to think of each sub-sample, each micro sample that it's taking as basically, remember our thought experiment of doing all of our math 1 pixel at a time? That's still valid if we do all of this 1 pixel at a time and then filter it back out to a result. So that was the motivation behind keeping all these samples in the first place. We just can't use traditional, we can't base our logic on a traditional raster. Hence, Nuke ships with a separate set of merge nodes and nodes for handling these deep files that will allow you to composite all of these samples intelligently. So let's go ahead and just look at that. We'll just look at compositing this. We'll use a deep merge here to merge our, we have a couple of ranks of robots here, a big robot and then a bunch of little robots. And the problem was this never would have really worked well for doing a classic composite, an over composite, because this big robot is sandwiched between these rows of little robots. And if we try to just do an over, it would either be on top of all of them or behind all of them. We could never sandwich it in one go. But with deep compositing, we can. So let's go ahead and drop down a deep merge. And the order almost doesn't matter because they're going to merge based on their depth from each other. So there we go. It's being sandwiched in between. And we can also do a deep merge. I'm copying and pasting it between these two. And get them all over the street. There we go. So that's allowed us to very quickly composite something that if we didn't have deep buffers, it would have been pretty much a helpless situation unless we'd run out RGB matte objects, but then we'd run into the whole problem of how do we filter the pre-multiplication. It might have been pre-multiplied against the wrong color background, and we'd have a very difficult time suppressing that. So this handles all of that for us. There's a bunch of other tools, and we'll look at them in the next video just for basically manipulating the color and stuff in deep, and also using these interchangeably with traditional images if you have like partially deep files and also files that are classic flat RGBA images. So we'll look at that in the next video.